Okay, we are standing up a standardized schema for mapping impact craters. And this is the first time that we're presenting it to the public, and we're looking for feedback or refinement on this schema. As mappers, every solid surface body in the solar system has craters, therefore we experience them in any area we set out to map. Next slide. However, there are known issues with representing craters on maps. For example, on the top with a simple crater, the impacted target material that's shown in white is exposed in the crater wall of a simple crater, or in the terracing walls, or possibly the central uplift feature of complex craters. So when we map these as crater units, we can imply a falsely younger age for the targeted material. Additionally, crater representations are not standard across scales or bodies, and this is something that we want to improve to enhance cross-comparison of maps in these situations. Next slide. So we started this schema by evaluating the published maps of the Moon and Mars, which account for roughly 60% of published maps, and which represent two end members of crater modification, since the Moon is an airless body and Mars has active surface processes. There's a variety of ways that craters have been represented in maps over time, either as points or just crater rims being mapped, or polygons as surface features, which means they're described in the explanation of map symbols, or they're actually mapped out as map units and described in the description of map units. So moving forward, we're recommending a combination of this. Next slide. So this schema recommends surface and units based on the print size. So that allows for standardized representation of craters regardless of body and scale. For example, craters that are smaller than 5 millimeters in diameter, or about the width of a pencil eraser, you can't really distinguish much about the crater, but you can identify it. So that will be a surface feature, either a point, line, or polygon in your explanation of map symbols. For craters in between 5 and 16 millimeters in print, or between a pencil eraser or a dime, you can start to identify more about the unit, and it'll be a larger surface area, so you map it as one unit undivided. Craters larger than 16 millimeters or larger than the diameter of a dime, you can split out actual units. For example, on the top, you have a simple crater, and you might be able to identify ejecta, wall undivided, floor, or for a complex crater on bottom, you'll have ejecta, wall undivided, floor, peak undivided. We use the term undivided to communicate to the map reader that both crater and or target material may be present and mapped at that scale. Additionally, this will be applied as appropriate by the map author. So this is more of a guideline than a strict requirement. Next slide. We want to stress that this does not replace existing morphological classification schemes. Instead, we're just standardizing how craters are represented on maps, which may or may not include morphologic classifications in those map products. Next slide. So as an example, building a 1:1 million scale map on Mars using a Themis Day IR base map. Next slide. The smallest category of craters that are not identified as a diameter in this image, at 1:1 million scale, 5 millimeter diameters would be 5 kilometers. Next slide. The medium-sized craters between 5 and 16 millimeters would be 5 and 16 kilometers at this scale. So the 5 kilometer, 6.8 kilometer, and 9 kilometer craters would be mapped as one unit undivided. Next slide. And then the largest central crater, which is larger than 16 kilometers, which means larger than 16 millimeters at print, we would start to split out the different crater units that we see. Next slide. So for example, it would look like this. We have 3 crater undivided units in yellow, and then the 4 crater units, crater ejecta, crater wall undivided, crater floor, crater peak undivided, listed in the description of map units. And then all the small category craters just have the crater rim as a line feature in the explanation of map symbols. Next slide. So we're looking for input from y'all as a mapping community, and then we're also soliciting feedback from those in the crater community. We want to expand this schema to be applicable to other bodies such as Venus and Mercury, but we understand there might be a refinement that's needed later for unique morphologies present on those bodies. But ultimately, we want this published as a USGS Techniques and Methods paper to disseminate it and let people use it as mappers moving forward to standardize crater representations. Next slide. So I look forward to any feedback you'll have during discussion time or reach out to us by email. Thank you. Does it really make sense? I see a question. To not map the rims as line features within the crater undivided unit. So there are some conversations that we're having on how to represent the undivided unit differently than in the past. So this is the first time that we're presenting it. So we wanted to distill all the discussions we've had to the bare basics of like what is happening. That is something to be considered as mapping the rims or not. If you go back 2 slides, please. We have hatcher patterns in the wall undivided and the peak undivided to like visually indicate to the reader that there's more than just the crater unit shown. If you add a rim line feature in the crater undivided yellow with a hatcher pattern that may or may not be there because it's undivided, it might get busy. So these are some of the combinations of colors and line and stipple patterns that we're talking about right now. But you make a good point, and that's noted for discussion. If you're including the ejecta in your undivided crater, shouldn't the diameter of the ejecta be defining the width and not the diameter of the crater? Yes and no, because not all craters have ejecta. And so for the most heavily modified craters on our bodies, what we're going to be looking at is the crater rim. So there are so many different morphologies that are possible with craters. So we're trying to simplify how to establish it, and every crater has a diameter. So we thought that would be the simplest way to make these size thresholds for representation. Because right now you get more information on the actual crater shape for smaller craters than those bigger ones in the undivided unit. I think that depends. Yes, that's a good point, because visually you can see more for the undivided because there's not contacts and like hatcher patterns and colors barring what you can see for the undivided, which are the smaller craters, versus the larger craters, which are split out. But there's strengths also to that if you're doing spatial analyses on the polygons for surface area covered or exposed of target material that is identified. The intent of the schema is to like be a starting point, and based on whatever each author has as a science goal for their map, this should be adapted. So if craters are a focus or you have a really unique type of morphology shown in your area, then that is something that based on these guidelines you can change, modify, enhance if you have more information you want to show on smaller craters. Why do you combine the outer crater rim with the ejecta? Preliminarily, right now we're working off of some schemas. I mean, I'm not a crater expert, so I'm trying to get more information from those who are. And we combine the outer crater rim because at the highest topographic inflection point at the top, on the outside of the crater, there is ejecta deposited at the top. If you erode that away, ideally the topographic inflection point would still go down. So you're starting to still expose the target material, which would be the crater wall. If that's not correct for the mapping area, then that should be adapted by the map author who is the expert for that area.